Hello. This video is provided as in just an optional look at computers, um, what's going on inside them, and a little bit of history of where they came from. First of all, as a programmer, you're going to have to deal with the binary number system at times. Humans usually use the decimal or base 10 number system. We've got 10 fingers, 10 toes. It comes naturally to us to count by tens. And you'll probably remember learning about this in elementary school. 7,562, as you see here, could be represented by 7 thousands, 500s, 6 tens, and 2 ones, which are all represented by powers of 10. Base 10 uses the digits 0 through 9. But a computer uses a binary number system, and that means it only uses the digits 0 and 1. In base 10, the number 7,562 is represented as you see the string of zeros and ones in binary. And this, if we mapped it all out, would be what that binary number looks like. These are the powers of 2 that represent the placeholder values for the binary number system. As a programmer, you will occasionally need to work with binary values, but usually you don't work with them actually as a string of zeros and ones. You usually work with them as octal numbers, as shown here, which is an octal number is base 8, which groups 3 binary digits together into one digit from 0 to 7, or you will use a hexadecimal number, which groups 4 binary digits together and uses base 16. Since we only have 9 digits in the decimal system, we use the letters A through F, capital A through capital F, to represent the hexadecimal digits represented by decimal 10 through 15. Just some background there because you will see them at times. In the computer, a bit is the name for the smallest unit of computer memory. It can hold a binary value of a simple 0 or 1. So electronically, it either has a positive or a negative charge in the electronics of the computer. A byte groups bits together into something meaningful. Usually 8 bits are grouped together to make a byte, and that can be represented by 2 hexadecimal digits. So when we talk about computers, and if you've ever shopped for a computer, you will see this when we're talking about either the memory or the storage on the hard drive or something like that. You will see it measured in bytes. Usually megabytes, gigabytes are common today. But a bit is just the 0 or 1. A byte is a group of 8 bits. A kilobyte is, in the metric system, 1,000. The closest actual value is 1,024, which is a multiple of 2. So technically, when you're talking computers, a kilobyte is 1,024 bytes and not just 1,000. And similarly, megabytes, a megabyte is a million bytes or 1,000 kilobytes. A gigabyte is a billion bytes or 1,000 megabytes. And a terabyte would be a trillion bytes or 1,000 gigabytes. So generally speaking, when we're talking about computer components, basically how a computer, the components work together at this point. But essentially, you're talking about binary information being transferred between input devices and output devices, between the central processing unit and storage. And when we talk about measuring the power of these systems, we talk about how much RAM or how much memory it stores in bytes or gigabytes. Storage space, we talk about gigabytes. Processing, we talk about speed. In other words, how quickly, how many commands it can process in a second. So just a little way back into history here. This is a picture of ENIAC in 1946. ENIAC was considered to be um, probably the first programmable computer. ENIAC stands for Electronic Numerical Integrator and Computer, and it was built at the University of Pennsylvania in 1946. Basically, it consisted of a bunch of many functional units that would be wired together in order to program them. So, for example, if you had a certain program that you wanted to run, you would, for example, if you needed to do a multiplication followed by an addition, the programmer, which is what these ladies here you see are doing, they would actually wire the units together in the correct order to perform the steps in your program. And once it all got wired up properly, which is the programming part, then they would run your program and see what the results would be. It wasn't too much longer. UNIVAC came along, 1951, which was called the Universal Automatic Computer. This one actually did not have to be wired by hand. You see, maybe, I don't know if you noticed in the previous picture, they were using vacuum tubes. UNIVAC brought in mercury delay lines in order to temporarily store computer code or the instructions for the computer. You'd have to look up exactly how that works. I can't tell you how mercury delay lines work specifically. But they also introduced, and you can see it on the right here, magnetic tape. So they were actually able to sit down at a console, and they did not have to go in and physically rewire things. It was actually done electronically at this point. They sat down at a console to type things in. They were able to store their programs on magnetic tape. Some of the early smaller systems actually were programmed with switches. What you see here would be the switches are either on or off, representing the binary values. So a programmer would sit down and toggle the switches on and off, and then the computer would read the panel of switches to load the instructions into the computer. This is a few years later. This picture is probably in the 70s. It looks like, and punch cards came along. They came along actually probably in the 60s, but they were still being used into the 70s and early 80s. In a punch card system, you can see they would sit down at a terminal like you see here and type in the program, and it would be punched as a series of holes into a card that would be read by a card reader on the computer. So you could actually sit down. You didn't have to sit down at the one and only console of the system. You could actually sit down at one of many places to key in or key punch your program, and then take it and have it run on the computer. Of course, there were problems. If you ever heard the phrase, do not fold, spindle, or mutilate, that's kind of where this came from. That phrase came from because if you bent your cards, they would not work anymore. If you dropped them and they all got out of order, hopefully you will have them numbered so that you could get your program back in order again. One of the next things that came along was what we call core memory. The top picture that you see, there are very small wires running through a series of little tiny magnetic rings. And to see the actual size of them, you can see them sitting down there on the lower picture on top of a $50. And basically the electrical charge running through the wires would change the polarity of the magnetic rings to either a positive or a negative charge. This allowed the memory to be maintained, the charge or the magnetic charge to be maintained after the power was removed. So it actually was able to store memory without power. So obviously we've come a long way. We're not having to run wires to program a computer. We've got some pretty nice equipment these days, but a program is still a set of instructions that the computer follows to accomplish a task. And the programming language is a structured language that is readable in English, but it is structured enough to follow certain patterns that the computer, the compiler, is able to recognize. When you talk about programming languages, the first programming languages were machine code. Obviously, the first programming was running wires. Following that, there were things like the switches, where you would actually toggle on and off the ones and the zeros, the binary code. And even today, the binary code is what a computer actually executes. But machine language was probably one of the first steps, or assembly language was one of the first steps that came and up from the actual ones and zeros of the machine code. You can see the little white box at the bottom there. What happened was they would take a binary code, which was an instruction, and they would create a simple mnemonic code for it, like in or out or jump. And then they would have a program that had already been entered into the computer that could translate the simple mnemonic code into the actual binary values. That was the first, they called that assembly language, and it was the ancestor of the compilers and interpreters that we use today. Assembly language is still being used for some things because it is very, very efficient, but it requires the programmer to know a lot about the inner working of the hardware because it actually interacts directly with the hardware. What you're going to be doing is using a high-level language, and most programmers use high-level languages. A high-level language is very much more abstract, human-like, easier to look at and understand what's going on, but it again requires a computer program to read it and to translate it into binary machine code. So that happens at a couple different levels. We have compilers or interpreters. The low level still exists, which is assembly code is assembled. Any of those will work together to create what we call object code, which is a binary representation. The object code is combined together with any runtime libraries. Runtime libraries would be things like code that knows how to access the hard drive and find files and do all those kinds of things. And that is combined together to create a complete executable code or complete program. And we use them every day. There are different categories of software. For example, we usually separate things into system software and application software. System software would be things like your operating system, device drivers, utilities. Application software are things like your browsers in Microsoft Office, games that you might want to play, or music or videos. Those would be considered applications. When we talked about binary values. In order to make that conversion from the binary to something readable that is human readable, characters that we can understand, they had to come up with a map, a representation or symbolic representation of what number would represent what kind of character. And the first shot at that was called the ASCII table or the ASCII code. ASCII stands for American Standard Code for Information Interchange, and it started out with these, you see 127 or 128 different values here. Some of them represent things like backspaces and tabs. They represent the upper and lowercase letters of the alphabet, the symbols on the keyboard, control characters, things like that. And those are still used today, but it was added onto in recent years by adding what we call Unicode. Unicode characters extend the ASCII character set and provide ways to represent characters in other languages, Chinese, Russian, accents on characters, and all kinds of special characters and icons and emoji. So you can see here there is a page from unicode-table.com that you can use to look up codes for all kinds of different things that you can represent in your programs. Just to show you here in the ASCII table, the decimal value 65, which is hexadecimal 41, represents the capital letter A. You will be using what we call an IDE, or an Integrated Development Environment. And basically what that is that is a program provided for programmers to make it easy for you to write your code, to compile your code, to test it, to look for errors and correct them, to debug your code. An IDE provides some benefits or tools that you wouldn't get from just typing your code into a basic text editor. And for example, you see that there's colors used on the screen here. That is actually feedback from the IDE to the programmer when it recognizes keywords, that they're spelled correctly, they're being used correctly. It highlights them in certain colors so that you can see what's going on. The code here actually that you see is C++ code. So it looks a little different than what you're going to be using in Python, but the idea of the IDE is very similar. Your IDE you're going to be using is PyCharm EDU. And this I threw in here just for fun. This picture is from about 1985 or 86. And this is the Luck Computer Center at the University of Washington, where I was working as a programmer. That's my daughter, you see. She's sitting on a hard drive. That hard drive actually had removable drives that you could swap in and out, and each one of them was, I believe, about 512 megabytes. That big whole box, it held about 512 megabytes. So you can see that that's way small compared to what you have on a flash drive that you carry around in your pocket today. But just for fun, that was the way it was. And I hope you enjoyed this little walk through some of the history of programming.